Let's talk about graphing parabolas. There are two types of parabolas that we're going to graph in this section. One type opens up or down, and the other type opens to the left or to the right. And before I show you where parabolas come from, on the next slide, I want to give you a little bit of an overview of some of the important parts of a parabola we're going to be looking at. First really important part of any parabola is what we call the vertex. And the vertex is either the very, very top or the very, very bottom of the graph. We usually use, by the way, the letters H and K to denote the x and y coordinates for the vertex. And if we have a parabola that opens to the left or to the right, we still will use H and K. They'll be the farthest left or the farthest right on our parabola. One other thing that's really important about a parabola is a focus point. And you might have heard that term before, but the focus point is always right. It's in the middle of the parabola, halfway between one side and the other side, and it would be approximately here for each of these parabolas. I'll show you where the focus point comes from in terms of a parabola in just a couple minutes. Before I show you that, though, the last thing that I want to write down before going to the next slide is the standard form for each of these parabolas. So let me kind of divide this into two parts, the top and the bottom. If a parabola opens up or opens down, the standard form or vertex form of the parabola's equation looks like this. X minus h quantity squared equals 4a times the quantity y minus k, where h and k is our vertex. A is the distance from the vertex to the focus point in each one of these. That's what that A is. If we have a parabola that opens left or right, the standard form is y minus k is squared and equals 4a x minus h. Okay, and A, again, is the distance from the focus to the vertex. Okay, let's look a little bit more at where these parabolas come from and how the focus is related to the shape of the parabola. Okay, here we have a picture of a downward facing parabola. And let's see, I'm going to make this circle go away in just a second, but you can see here that the circle, let me get my pointer, this circle right here would have the center as a point on the parabola. And here's what's important about our parabola here. The distance from the point on the parabola to this focus point right here is the same, because it's the radius of the circle, as the distance from the point on the parabola to this purple line. This purple line has a name. It's called the Directrix. So this black line that goes from the focus out to the point on the parabola is the same as the distance from the point on the parabola directly to the Directrix. Okay, so using that circle and the radius of that circle is how we get the equation of the parabola. I'd like to have that, go away. So let me open this back up. Okay, that's better. And now we can see, let me change colors here, a couple of things that are important. Blue would be great. Okay, so this distance here, whatever this is the same as this distance here. This line up here is called the Directrix. Okay, so the distance from the focus, which I'll do in red, to any point xy on our parabola is the same as the distance from that point to the directrix. Now, the point that I really want to talk about right here is the vertex. So let me erase the stuff I just did. I want to show you this. So the distance from here to this point, we said was A in the previous slide, and that is the same as the distance from the vertex to the directrix. Okay, so this might have, let's see, if we say that the vertex is at the ordered pair h and k, we would probably have a downward facing parabola. We have a downward facing parabola here, so it would be x minus h squared equals 4a times y minus k. Depending on how your textbook defines this, if it opens down, sometimes the a includes the negative, so a would be less than 0 if it opens down. And if our a had happened to be positive, then this parabola would open up. Okay, let me show you one more slide before we start a new example. So here, let's see, I want to open this one. Okay, so if you take a look at the graph we have here and then the equations on the left-hand side, we have y equals x squared over 4p. So this graph in Desmos put the 4p next to the x squared. And if they let me move the point around, if I move the focus, which I'm moving right here, moving the focus further away from the vertex creates a wider parabola. And if I move the focus really close to the vertex, I have a really narrow parabola. And you can see that the focus and the vertex compared to the focus and the vertex, that would be distance A, compared to the focus and the directrix and the vertex rather, that would be the same distance A. Okay, let's use this and do some examples. So for graphing parabolas, the things that you want to remember are if they open up or down, we have x minus h squared equals 4a y minus k, where a is the distance from the vertex to the focus and from the vertex to the directrix. Likewise, if our parabola opens to the right or to the left, we have a is this functions in exactly the same way. We just have y being squared, so y minus k quantity squared equals 4a times x minus h. Okay, let's do an example. Let's say that we have to graph y minus 3 squared equals negative 8 times the quantity x plus 2. Now, whenever you have to graph a parabola, you are going to have to find and label the vertex, the focus, and the directrix. Okay, so let's get started. So looking here, let's see, we have y minus 3 and x plus 2. The first thing I want us to notice is, by the way, that the y is what's being squared. So this graph, let me highlight this, because of this, will open left, whoops, let's try that again, there we go, left or right. Also, since it's a negative, it's going to open to the left side. So I can cross out the right. Okay, and the vertex, I'm going to look at the h and the k. So the vertex is going to be, make sure you have the number that goes with the x value first. So -2, we're going to change the sign, and the k would be 3. Okay, and so let's start graphing that. So we've got x equals -2, and y equals 3. So there's our vertex. I'll label it with a V. Second thing, we need to find the focus. So the focus point, to find the focus and the directrix, we're going to look at A. So now remember, the number in front, let me highlight this with a different color. The number in front of the parentheses was equal to, let me go down here, 4a equals -8. So if I'm solving for a, divide both sides by 4, and we have a equals -2. So since the a is negative, and we had a y squared, remember we're going to the left, so I'm going to travel to the left 2 spaces. There's my a. So let's see, that puts me at still y equals 3, but apparently 2 would be at -4 for x. So -4, 3 would be the focus point. Cool, so there's my a distance. And then going backwards going the other direction, going to the right 2, puts me right on top of the y-axis. That would be my directrix. So it would be x equals 0, or you could say the y-axis. Okay, now I know my parabola looks something like this, but I don't know exactly how it looks. So let me show you a great way to get a nice picture for your parabola. Starting at your focus point, we're going to travel 2a units. So 2 times a would be 2 times 2, which should be 4. We're going to travel 4 units on either side of the focus. So 1, 2, 3, 4. That's 2a. And the other way, 1, 2, 3, 4. That's also 2a. And I can draw my parabola through these points as well as possible. That red dashed line right there has a special name. It's called the Lattice Rectum, and it is 2a through the focus on one side of the parabola and 2a through the focus on the other side of the parabola. It's a nice way to really get a good idea of how wide your parabola is. Okay, so whenever you're answering these questions, remember you need to always put your vertex, which we have here, your focus, which we have here, and your directrix, which we have here. Okay, let's do another example. Let's say we have to graph x plus 4 all squared equals 12 times the quantity y minus 1. So this problem, since the x is being squared, I do want to go back to the highlighter. Since the x is being squared here, and since the 12 is positive, we know that our graph is going to open up or down. And since 12 is positive, it's going to open up. Okay, we further know that the vertex is at -4, 1 from looking at the x minus h and the y plus k. So let's start graphing that. So I've got 1, 2, 3, 4, -4 for x and 1 for y is our vertex, which I'll label with a V. We know it opens up and down, we just don't quite know how far to travel, so now let's find the focus and the directrix. And to do that, we're going to find A. A will tell us where the focus and where the directrix is. So 4A is equal to, in this problem, 12, which means that A is 3. Now, since A is positive, and we know the graph opens up and down, we're going to go, whoa, that positive doesn't look very good. Let's erase that. Positive, greater than 0, then we're going to travel up 3. So 1, 2, 3, and that will give us our focus. So if we start, it looks like we're still at x equals -4, but if we travel up from 1, 1, 2, 3, now we're at y equals 4. So it looks like the focus is at -4, +4. Also, since A is 3, we're going to go the other direction, 3 units, down, 1, 2, 3, and this will give us our directrix. And that appears to be at y equals -2. So starting at the vertex and traveling down 3, 1, 2, 1, 2, 3, puts us at the line y equals -2. Okay, and then finally, to get a nice pretty picture of what the graph looks like, take your A, or rather the absolute value of A, and multiply it by 2. So 2 times 3. This is how wide to make your graph going through the focus. So if we start at the focus 1, 2, 3, 4, 5, 6, and we travel 2A units to the right, and I'm going to go way off my curve, 1, 2, 3, 4, 5, 6, but I know if I have one side, I know the other side is symmetric. Looks something like that. Great. Okay, let's do a couple of examples where to find the vertex and all the other information, we have to use completing the square. So here's how we're going to do this. When we graph x squared plus 6x minus 4y plus 1, what I want you to notice is that only the x has a square. The y, there are no y squareds in this problem, so that's how I can tell it's a parabola. And here's what I'm going to do. I'm going to put the x squared and the 6x, keep those on the left-hand side, leave some space for me for completing the square, and move the 4y and the 1 over to the right-hand side by adding the 4y and subtracting the 1. Then I want to use completing the square. So if you remember, we're going to take the -6, and I'm sorry, take the -6, take the 6, cut it in half to get 3, and then square that to get 9. And that number, we're going to add on the other side of the 6x. Now, in order to balance the equation, of course, we need to add that 9 to the right-hand side also. So here's what that gives us. That gives us x squared plus 6x plus 9. That factors really nicely. It factors to x plus 3 all squared equals 4y plus 8. So I love the left-hand side of that equation. It's parentheses squared, so I can start to see where my vertex is coming. Now, on the other side, on the right-hand side, I really want this y to have a coefficient of 1. So I'm going to factor out whatever current coefficient it has. So I have x plus 3 all squared equals, take out that 4, and that leaves us with a y plus 2. Terrific. Now I can see that I have a vertex at -3, -2. Okay. I can also see that since the x is being squared, and since this is, the x is being squared, and since this is a +4 in front, I can also tell that this opens up. Okay, so let's start graphing this. Let's go back to black. We've got the vertex was at -3, -2. 1, 2, 3, 1, 2. So here is my vertex. To get the rest of the graph, I really need to find A. So 4A equals the coefficient of the parentheses on the right-hand side. So 4A equals 4, which means that A is equal to 1. And since A is positive, and we know we're going up and down, we're going to travel up 1. There's A. And that gives us our focus. So let's see. It looks like the X value stays the same because we're just moving up. So that's -3. And the Y value moved up 1, so now we're at -1. So our focus is at -3, -1. You can move the same direction, the other side of the vertex, so going down 1, and that will give you where your directrix line is. So this directrix is at y equals -3. Okay. Okay, and the last thing to do to get a really nice picture, let's do this in black. If you take A and double it, so 2A, in this case, is 2 times 1. That tells me how far to go on either side of the focus. So let's see, I'll go 2 units to the left and 2 units to the right. Forgive me for drawing my parabola right through my letters here. We've got a nice picture of what our parabola looks like. One last example to do with parabolas. So again, just like in the last one, I want you to notice that the y is being squared and there are no x squareds. So this is definitely a parabola graph. So just like I did in the previous example, I'm going to keep the y squared and the 2y on the left-hand side, but I'm going to add the 16x to the other side with the 33. And then I'm going to use completing the square on the left-hand side. So 2 divided by 2 is 1, and 1 squared is 1. So if I add a 1 to the left-hand side, I should get something that factors beautifully. I just have to balance, and I have to add 1 to the other side too. Okay, terrific. So now I have y squared plus 2y plus 1 factors to y plus 1 all squared. And the other side becomes, this is 16x, minus 32? Go back. Minus 32. Remember, we want the coefficient of the x to be 1, so we'll factor out the 16 and get x minus 2. Perfect. Now we have our vertex form for our parabola, so we can tell a bunch of information now. We can tell that the vertex must be at 2, -1 from the h and the k. We can further tell, since the y is the one that's being squared, it's a left-right parabola. And since the 16 is positive, that tells us that it opens to the positive side. Okay, so let's start graphing some pieces of that. Let's see, let's go to the vertex. Is it x equals 2 and y equals -1? There's our vertex. We know that it opens to the right, but we need to figure out what A is to find the focus. So 4A in this problem, oh there it is equal to 16, which means that A equals 4. Since our graph opens to the right, we know we're going to go to the right 1, 2, 3, 4. And it looks like that keeps us at the y value -1, but moves us 4 units to the right of 2. So 3, 4, 5, 6. So our focus is at 6 for x, -1 for y. And we're going to go the opposite side for the directrix. 1, 2, 3, 4. And wherever we end up is where our directrix is. Let's see, that's -1, -2, so we're at x equals -2 for our directrix. And then finally, to get a really accurate picture, we're going to take A, multiply it by 2 to get 8. And this is going to tell us on either side of the focus how far to travel. So 1, 2, 3, 4, 5, 6, 7, 8. Just barely made it on there. And I'm not going to be able to go down that far. My graph doesn't go far enough down there. But I do know that it's symmetric. So I know it's a mirror reflection on one side and the other side of the vertex. So I guess I could go down off this graph 1, 2, 3, 4, 5, 6, 7, 8 approximately. We'll make that bigger.